Okay, good afternoon, everyone. Okay, um, so we talked yesterday about solving systems of three equations with three variables and the process that we go through to do that by hand. So for this warm-up, instead of doing that again, I actually wanted to show you a different method that we can use really quickly. I don't know, it's not super quick, but it's quicker than doing by hand. Um, so I still do want everyone to send in that checkpoint to me. If you haven't sent me that checkpoint already, please do. Okay, of the any two of those four systems like this that I sent, and for that checkpoint, it should be showing me all the work of the solving. But I'm going to show you a different way you can do it right now using your graphing calculator. Okay, so like the email said, if you have your graphing calculator with you, that would be awesome because I'm going to teach you a really good way that you can solve this just purely on your calculator without needing to do any work by hand. So let me bring up that calculator. Well, actually, we have to do a little bit of a preliminary setup work before that. And what we're going to do is we're going to create what's called a matrix. Um, college algebra kids know what a matrix is because we talk about matrices in college algebra. Math analysis, we don't really. We don't have a unit on matrices at least. So I'm just going to give you a super little crash course. We don't need a ton. But what's going to happen is I'm going to create a matrix just based on all of the coefficients of these numbers here. Okay, so I'm just going to go across -2, 2, 1, 14. 3, -2, 1, -5. -1, 1, -2, -8. All right, this is what is called a matrix. Right, and it's basically just a box with a bunch of numbers in it. Okay, to put it simply. But when we use this, we can use this to solve systems of equations. And so actually in college algebra kids that took my class last year, we talked about matrices a lot. I don't know that I showed you ever how to do this on your calculator. So I think this might be brand new for everybody, unless a previous teacher taught you how to do this. But so please, if you can, by any means, have your graphing calculator with you right now so you can do this with me because it's kind of a long process of buttons to push. So bring it with you so you can follow along. All right, let me. Okay, let me pull this up here. So the first thing that I'm going to do is we need to bring up like the page on our calculator that deals with matrices. So I don't know if you'll be able to tell, but if you just have a TI-84, there is a matrix button on the very left side. It's underneath math, right? But you'll notice it's written in blue. So that means we have to click second and then x to the first power, and it should bring up a page like this. Okay, so again, your matrix button might be somewhere different, but if you have a TI-84, then you click second, x to the negative first. So basically, that's the matrix button. All right, it brings up a page like this. We want to enter in our matrix. So all these numbers that I wrote out in blue, these are our matrices numbers. So we're going to go to the right to that tab that says edit. So I'm just going to go right to 1, 2. So you'll notice it looks the same almost as that first page, right? So I'm going to go back. This is where you start at. It says names and then A, B, C, D, E, F, G. But we want to go over to edit where it says A, B, C, D, E, F, G. Edit is for when you want to put in new numbers into the matrix. So we can have a bunch of different ones. Let's just use A. That's probably the easiest way, is we'll always just use A. So I'm going to click 1 or enter, whichever one. And it brings up, it should look like something like this, assuming that you've never typed in numbers before. So up at the top here, it's blinking. It says 1, and then there's an X, and then 1. Okay, what that is asking for is it wants to know how many rows are there in this matrix and how many columns. Okay, well, so rows go across, columns go up and down. So looking at the rows, there's 1, 2, 3 rows. So I'm going to put a 3 there and click enter. So now I should see that my matrix made 3 rows. And then there's 1, 2, 3, 4 columns. So I want there to be 4. And then I'll click enter. And I can see that now on my calculator, there is a matrix that has 3 rows and 4 columns. It kind of goes off to the right side, but that's okay. Let me try to make this a little bigger. Hopefully that helps a little bit. All right, so now we're just going to enter in all the numbers from our matrix. All right, so our matrix is what I wrote in blue, so I'm going to click, first up is -2, so the negative sign 2. And then to go to the next spot, I just click enter. So enter, I can see that it put -2 in that first spot, and it goes across the top, so the next one would be +2, enter, +1, enter, +14, enter. And now I'm down to the second row. So now I start at the second row and go across. 3, enter, -2, enter, 1, enter, -5, enter. And then the bottom row, -1, enter, 1, enter, -2, enter, -8, enter. So I should have all of my numbers from the matrix entered in here. Okay, so before we do our next thing, we just want to quit out of this. So everything's entered in this matrix. So now I'm going to just quit to go back to the main screen. So I'm going to do second mode. Right, so that just quits and puts me back to the main screen, right? Second mode. And now I'm going to go back to my matrix stuff that I had before. So same process I wrote above. The matrix button is behind x to the negative first. So second x to the negative first. So it brings up my matrix page. And now I can see that it says, right next to the A, it says 3 by 4 because we entered in a 3 by 4 matrix there. So we know that it has the numbers stored in there that we want. Okay? But now I'm going to go right so that I can see in the middle of the screen, there's a math tab. So if I go, we went all the way over to the right to edit, but now I'm just going to go over to math. And it brings up, should look like this. I'm going to scroll down a bunch until I get to RREF. Now, RREF, that is something that us college algebra people talked about last year. It stands for Reduced Row Echelon Form. Right, if any of them remember that. But it doesn't, that doesn't matter. You don't need to remember that's what it's called. But you do remember that's what we need is RREF. So I'm going to click enter. So it brings up RREF on my main screen. And now what I want is I want to put that matrix A inside of there. So I'm going to go again. I need to go to that matrix page. So the way that we get to matrix is we go second, x to the negative first, second, x to the negative first. So it brings up this same page, right? We've gone to this every time in each step. And now I just want this matrix A. So I don't even need to click anything more besides either click 1 or click enter right here. So I'll just click enter. So that matrix A is inside of the RREF. Mine showed up below the matrix and not on the main page. Okay. So here's, all right, so I'm going to pause. I'm going to go back to that. So Megan, so when you're editing, so first, Megan, make sure all your numbers are actually what you want them to be. I think what happened is you probably typed in RREF right here where the -8 should go. So make sure that you have all the actual numbers that we originally typed in. This is what is in the matrix. Are you good? Do you have that? Yes, okay. So once all of our numbers are entered here, we have to, before we go to the matrix thing again, we have to quit out of this completely to just go back to our main page. So second mode, so that you're just back at the home screen, fresh start. All right, second mode to quit. Now, if we go to that RREF, so second, x to the negative first, go to the right so that we're on the math tab, and now scroll down to RREF. All right, it's kind of a ways down there, so you got to scroll for a little while. So RREF, then it should bring up just RREF on the main screen. Did that work? I see now. Okay, great. So RREF, and then we want that matrix A, so second, x to the negative first. It's already on A right there. So enter, close the parentheses, and click enter again. And it should bring up a matrix that looks like this, where those first 3 columns are just zeros and ones. And then on the right column, there's actual values, actual numbers. So what those numbers represent are our answers. Right, so the first variable we had was x, so that very top number, -3, so that tells me x is -3. Second variable we had is y, and so that second number down on the right column is 1, so y equals 1. Third variable we had is z, so that third number down is 6. So boom, our solution is -3, +1, +6. Hopefully everybody followed along with that. Okay, again, I know it is still kind of a lot of buttons to push, but once you get the hang of it, once you've done it a couple times, then it's you remember the process. You don't have to sit there and think, wait, now do I go here or here? And so it's better. I don't know. I think it's better than doing out those systems by hand. Okay, especially like, well, one day, 10 years in the future, whenever we all go back to school, and you'll have to actually like take the ACT or AP test or whatever it is you're ever taking, and you have a graphing calculator and you have a system of equations, well, you can solve it using a matrix. You don't even need to do it by hand. Okay, so very helpful. All you have to do is what we did at the start. Take the system, however many equations there are, or however many variables, and just turn it into a matrix that looks like this. Enter it into a matrix on your calculator, and then use that RREF to solve it. Okay. Again, hopefully that went well. So yeah, I mean, I taught you how to do it, so use it when you can. Use it, on a PFA, or, use it whenever. I do still want, again, that first checkpoint, I do still want you to send me that is just solving it out by hand, just to practice doing it, because I just need to know that you can do it, because we'll need it. We'll need to know how to do it for calculus, right? We'll do some stuff that involves solving systems like that. And actually later on in this unit, there'll be a system that we explicitly will have to use to solve in calculus. So still do that checkpoint of those two systems, whichever two from the homework. All right, send that to me. There's still a handful of people that haven't, so make sure you get it to me. I also went through and replied to everybody. If you sent it to me so far and you had a mistake of some kind, then I sent you back where you should look for the mistake. Cassidy, yes, I just got yours. I haven't had a chance to look at it yet, though, because I got it just before class. But for everybody else that emailed me at some point earlier in the day, if you got it perfect, then I didn't reply. If you had some sort of error, then I replied and told you somewhere that you need to fix. So please do fix it and send it back to me again. I want to because again, I need to make sure that we can do this, because it'll be very important later on. However, use this on your graphing calculator to check your answers. Use it on the PFA. Okay, very helpful tool. Mine is perfect plus extra points for color. Wait, Megan, did you send me yours? Yesterday. Hold on, let me look. I must have missed that. What was yesterday? Wednesday? I don't see it, Megan. Can you send it again? Yeah, I don't see it. She's pretending that she sent it. That's classic. Like whenever the teacher asks you, where's your homework? And you don't have it or you didn't do it, but you're like digging through your backpack anyways. You're like, oh, I know I had it in here. Where is it? Dang it. What the heck? Opening folders, knowing good and well that it's not there. You sent yours at 10:24. I mean, well, no, yeah, you were good. Ted Bundy fan 23. I got yours. Yours was fine. Again, I only sent a reply if there was some sort of issue. I can send replies though too, just to tell you that I got it if you guys want to. All right, Megan, I got it this time. I mean, I got it since this is the first time you've ever sent it. She did it just now. But wait, I just got the email, but I didn't even look. I'm sure. Did you actually just like attach like blank pictures? And then later when I look and I'm like, oh, these are blank. And you're like, what? Oh my gosh, they're blank? That's crazy. I sent real pictures. Why did it mess up like that and send blank ones? Ah, crazy. What a world. I told myself no naps. Good job. All right. It deleted my work. What? Why did it do? What the heck? Summit's being so stupid. I like it. Like suddenly like refreshed and all my stuff was gone. Some of my favorites. I remember using those. Okay. I'll go through and send emails to those of you that sent it um, and got everything correct. So I'll respond to everyone so that after class to make sure that you know that I got it from you. My dog, well, my dog ate my laptop. I did it on my laptop and my dog ate it. My dog ate my Apple Pen, so I couldn't write my homework. Okay, let's talk today a little bit about nonlinear systems of equations. So nonlinear systems now, we're talking about for us, there's more than this, but we'll just talk about equations that have x squared and y squared in them. All right, so it's no longer just a system of linear equations like these were. Right, these are linear. These are all the variables are just to the first power. But now let's start adding in variables that are squared. Okay, quadratic terms. Dogs yell at me. What does that even mean? So for these problems, we're still using our basic solving methods that we've learned from like Algebra 1, Algebra 2, and like we've just did with systems, right? Why is this doing this? We're still using substitution and elimination. Okay, our main methods of solving systems. And then one of the main differences here is we could get, I guess, all right, up to we could get up to 4 solutions. And that includes 0. We could get no solutions, just like in our last problems. We could get 1 solution. We could get 2 solutions. We could get 3 solutions. We could get 4 solutions. All right, so there's no set amount. So be super careful. The biggest issue with these types of systems is people always forget. They like end up missing one of the solutions, or they miss 2 of the solutions because they stop too soon. All right, so just make sure you're getting all the solutions that you need out of your systems. So we'll just do a couple quick examples today. First of which, x squared minus x minus y minus 1 equals 0. All right. 3x minus y minus 4 equals 0. So this is kind of a more basic system. There's not a ton of, the only squared term there is in that first equation. There's just an x squared. So we'll eventually get to equations that have x squared and y squared in both equations. But this one only has one quadratic term. And so this would be really nice for us. In my second equation, I just have a single y variable, like a minus y. I'm going to go ahead and solve this for y. Right, I'm just rearranging that equation. Oops, wait a minute. So that would be negative y equals negative 3x plus 4. So y equals 3x minus 4. And I'm going to take this now and substitute it into my first equation. X squared minus x minus 3x minus 4 minus 1 equals 0. Now it's just time to do some simplification. So I'll distribute the minus sign to both of these. X squared minus x minus 3x plus 4 minus 1 equals 0. X squared minus 4x plus 3 equals 0. So we're at the point now, which we'll come to in all of these, where we have to solve a quadratic. So we have various ways that we can solve a quadratic. We could, or depending on what the quadratic is, but potentially we could use square root, we could complete the square, we could factor, we could use the quadratic formula, even though the quadratic formula sucks, and we try to not use it as much as we can, if possible. But the first thing to always look at is, can I just factor this? Because a lot of these we'll just be able to factor. And in this case, I can see that's also true. X squared minus 4x plus 3. Two numbers that multiply to make 3 but add together to make negative 4. So that would be negative 3 and negative 1. So x minus 3 times x minus 1. Set each factor equal to 0. X minus 3 equals 0. Then we get x equals 3. X minus 1 equals 0. Then we get x equals 1. Okay, so we can already see I definitely have at least two different solutions because I have two different x values. So now we need to figure out what is the y value for each of these x values. Right, so I'll have a separate case for each one. So the first thing I'm going to do, let's look first at x equals 3. I need to take 3 and plug it into one of my original equations. Probably the easiest one to do that to. I'm trying to solve for y. So I already have a really nice equation here for y. So why don't I just use that? Y equals 3x minus 4. Okay. Y equals 3 times x. We know x is 3. Minus 4. 9 minus 4 is 5. So what that means is one of my solutions is if I plug in 3, the y value that I'll get is 5. So 3 comma 5 is one of the coordinates that's my solution. Now let's do the same thing, but with 1. So we use our same y equation. That doesn't matter. So y equals 3 times x, but x is now 1, minus 4. So 3 minus 4 is negative 1. Great. So my other solution that I have, I know if I plug in 1, I will get negative 1. So 1 comma negative 1. These are my two solutions. Let's see what is actually happening here. So let's graph these. Because a good way to recognize solutions is by graphing equations, whether they're linear, nonlinear, whatever. If I could get this to pull up. Here we go. All right, so let me type in my original equations. So x squared minus x minus y minus 1 equals 0. So that's a parabola. And then my second equation, 3x minus y minus 4 equals 0. That's just a line. And so I can see these two equations intersect in two different points. 1, negative 1, and 3, 5. Well, 1, negative 1, and 3, 5, those are exactly the two solutions that we found, right, algebraically. All right, so that's what we're doing when we solve these equations. We're finding where do these curves intersect. That's why, since we're dealing with nonlinear equations that can curve and do weird things, we have parabolas, hyperbolas, ellipses, circles, and such. So that's why we could end up at intersecting at 1 points, 2 points, 3 points, 4 points, or no points. Okay, let's do one more. Today, at least. Negative y squared plus x minus 11y minus 30 equals 0. 2y squared plus x plus 22y plus 60 equals 0. All right. We can make a choice here whether we want to try to eliminate the x's or eliminate the y's. All right, just like usual. What do you think? What do you want? Eliminate x, eliminate y. M. Y it is, Cassie. All right, so my coefficients are negative 1 and positive 2, negative 11 and positive 22. So the only thing to be careful of is if we're going to eliminate y, then it has to be that when we add our equations together, we get rid of all the y's. The y squareds are gone and the y's are gone. Okay, now for this one, I think I can see that is going to work out. Let's take this first equation, multiply it by 2. And then the second equation we'll just leave as is. And we'll add them together. Negative 2y squared plus 2y squared is 0. 2x plus 3, or 2x plus x is 3x. Negative 22y plus 22y, 0. Negative 60 plus 60, 0 equals 0. Okay, so this worked out. Again, be careful. If it turns out that only one of the y terms cancels, like if maybe the y squareds cancel but the y's didn't, okay, then I would want to go back and choose something else. So I either want to eliminate all of the x's or eliminate all of the y's. But it worked out well here that we were able to eliminate all of the y's in one step. 3x equals 0. So dividing both sides, we get x equals 0. So now I need to go back through and plug in x to solve for y. We can choose either the first equation or the second equation. It does not matter. I'll choose the second one. 2y squared plus x, so that's plus 0, plus 22y plus 60 equals 0. Again, I'm going to try to solve this. I'm going to try to factor. So I see that each of these terms has a 2 in it. So I'll factor out a 2. Y squared plus 11y plus 30 equals 0. Okay, that's nice because y squared plus 11y plus 30 factors into y plus 6 times y plus 5. Solving that, I would get y equals negative 6, and I would get y equals negative 5. So when I plug in 0 for x, I actually get two different y values. So one of my solutions is I plug in 0, I'd get negative 6, but also if I plug in 0, we get negative 5. Right? This one single x value gave me two different y values when I plugged them in. So that's why the 0 is there for both. Okay, let me put this in Desmos again so we can see what's actually happening. So negative y squared plus x minus 11y minus 30 equals 0. And 2y squared plus x plus 22y plus 60 equals 0. Let's zoom out a bit. So these are both two parabolas. Why is Smart Notebook so slow? It's a big program. Our laptops sometimes aren't well equipped to handle it. Wait a minute, are you on the roof again? Is it overheating? It's not that warm outside. All right, so here's where those two parabolas are intersecting. I wonder where they intersect. Gee whiz. 0, -5, and 0, -6, which is exactly the two values that we solved for. No, it's too cold. Well, see, this is perfect. Yeah, when the UV index is low, that's when you should be outside. That's when it's safe. No Tegenio. Well, that's a valid argument. Then you don't tan. Yeah, good. Taiwanese. So, yeah, there's our 2 points. That's what we solve for. So tomorrow we'll do a couple more examples to see various other ways that we could solve these systems. Again, make sure I get your checkpoint from yesterday, right? And even though I showed you how to do it on the calculator, that's great. Use the graphing calculator to check your answers or to use it in the future. But I do want to see you doing these systems out by hand. Okay, and if you needed to fix something, all right, then fix that and send it back to me again. I want to make sure that we're all able to do this because it's not that it's the hardest thing in the world, but as you guys who have done it probably know, there's just so many little details. There's so many tiny spots where one wrong thing can screw up your entire problem. Okay, which if I've emailed you back, that's pretty much what I've said is, oh, you just missed this negative, or oh, you forgot to add this number, or you didn't distribute to this one number. Okay, something like that. So do fix those things and complete those things. Send them back to me and I'll keep having you correct them until they're perfect. It's just 2 problems. All right, I know they're kind of long, but it's just 2 problems. Otherwise, no homework from this assignment today or this lesson today. So just if you need to finish up that checkpoint stuff, I'll probably go put in the checkpoint in Summit, like enter it into Summit this afternoon. So if you have it perfect and you're good to go, then you'll see that on there. If you're still working, then you'll see that as well.